All right.
All right.
Did you do all the prep assignment, like the part 2 and everything?
Let's see, how far did I get? I didn't get very far.
Okay. So do you want to go over that before we start the quiz, or?
Yeah, I guess I kind of had a hard time understanding it. But I think if we go over 1, I think I should be okay.
Yeah. How far did you get? Which one do you want to go over?
Let's see. So,
because I was kind of having a hard time with it too, and then there was like video tutorials for each question, so I just went through it that way.
Okay.
But if there's a specific one you want to go over, I think I wrote them all out so we can kind of walk through it.
Okay. So I guess let's just do, let's see, which one do you think would be a good one? This information.
Number 6 would probably be a good one.
Okay. That's kind of what I was thinking.
Okay. Or like number 7's pretty much the same.
Okay, let's do 6.
Okay. All right, so you have it tells you your average, which is like the mean score. 150.8, and then it gives you your standard deviation.
Yeah.
So that's kind of like the answer to part A. So then part B says, what proportion of the people who took the quantitative portion of the GRE will score above 165? So for that one, what you have to do is you use the Z formula, like the Z equals, do you have that formula?
I do.
Okay. So what you're trying to find is Z, because then you can plug it into that applet, like the thing. I don't know if you watched the videos that he posted, Brother Richmond. Did you watch his videos?
I did not watch that video. I was watching, I seriously was trying to figure out the SPSS.
Oh, okay. So there's like this little app that you use that'll let you find out kind of like all the information without doing any calculations. So it's kind of nice.
Ooh, okay.
So what B is asking you for is to find Z. So you go Z equals, so the 165 that it says, that's your X. So you plug that in for X.
160 minus the 150.8.
Yep.
Okay, Shanna just responded. Let me invite her again.
Okay.
Sorry. My music too loud. I can turn it off.
No, it's I like music too, so it's good.
Okay. All right. All right. I sent that out. Okay, so you do 165 minus 150.8, and that's over your 8.8.
Yep. And so that'll give you your Z score.
You said it was an app that you can just download?
Yeah, well, so what I did is I went on from iLearn. I went on to our class.
Yeah.
And then you pull up the lesson, like the prep for this week. For lesson 5, go into the reading.
The reading.
Here, let me share my page so you can kind of see what I'm doing. It might be easier that way. Okay, so you can kind of see it now?
Yeah.
So lesson 5, and then just go to the normal distributions reading. Scroll down here a little bit. Where is it? So it's this thing right here.
Yeah.
There's a point where it's right here. You can I just loaded that in the new tab and then saved it as a bookmark so I can just pull it up really easy. So once we just figured out our z-score. What did you get for the z-score?
I got, if I did this right, 1.61.
Yeah, so you can just put that in here, 1.61. And then that'll give you what it's looking for right here.
Oh. And I saw it, but I didn't really.
So wait a second, hold on. What proportion of the people who want to think? Okay, yeah. So you put in, let me think. I'm trying to remember how I did it yesterday now. Crap. So it wants to know how many will score above
165.
Yeah. So this is okay. I think. Okay, yeah, that's right. So see how so it wants to know how many score above above 165. So this is the line for 165. That's what your z-score was.
Okay.
And then so you can kind of like click it here and unclick it. So if you wanted to know how many would score below 165, you would highlight everything over here. But it says who will score above 165, then you just click here and that gives you the proportion.
Okay.
I'm probably not explaining it very well, but there's some videos that he posted.
Okay, I will check out the video. Okay. Don't worry, but thank you.
Yeah.
And then, so pretty much you can use this little applet to answer the questions.
Pretty much, yeah.
Okay.
I mean, that's all it really does. And then there's some videos like here. If you go back to the reading, and like click on this right now. So you see over here on my left side, right here, these video tutorials go through each problem and explain it.
Oh, they do? I've never clicked on that. Okay.
So that's what I did because I didn't really understand it either. So I was like,
okay,
confused.
All right, I'll have to go back and watch those.
Okay. And we can refer back to that if I'm forgetting how to do it for the quiz.
All right.
So, is this... Hey, Shauna, how's it going?
Good, how are you guys?
Good, sorry.
No, you're good.
What did you think of the lesson this week? Or the second part?
I thought it was interesting.
Yeah, that's a good word for it. Interesting.
Yeah.
I think one thing I was thinking about that I wanted to see if I could understand better, in the book, on the first example, it talked about like, or the first two examples, it talked about the mean and the standard deviation, and like how to find
the z-score?
Yeah, the z-score for it. And I was trying to understand, on the first one they did multiplication, but on the second one it was division when it came to comparing like the standard deviation to the first answer they got. Does that make sense?
Oh, were they checking their answer? Was that like a way for them to check the answer? Like you do the opposite of division, so you do multiplication?
I don't know, because in the first example they did it by multiplication, but in the second example it was division. Did you guys see that in the book?
Let's see, in the book you said it was the first example. Was it about the batting average?
Yeah, so I remember like the numbers were like 159.0 and 169.0. Do you see that?
Okay.
So that one, eventually it goes to like, it was twice as much, so 2 times 4.9 equals this. But then if you kept going down, the second example, they did it by division instead of multiplication. So I was just trying to understand why it was different.
Oh, okay. So you're talking about the introduction to z-scores?
Yeah, I think it's that one.
So I think what they were doing before is like the 169 minus 159.
Mm-hmm.
So the 169 was his height. The average was 159,
Mm-hmm.
or her height. And so they found out how far away she was from the mean.
Mm-hmm.
And earlier in the problem, it tells you that the standard deviation is 4.9. So when it shows the multiplication 2 times 4.9, that just means it's 2 deviations from the mean.
Okay. So,
And then
okay. So if it was 3 standard deviations, then you would multiply times 3.
Yeah.
Okay.
Well, because it just says it's roughly like that squiggly equals sign. It says it's like roughly 2 deviations away. Because like, here, let me do this. So can you guys see what I'm showing here?
Yeah.
So like here, it's saying like this is how tall she was right here, and then this is the average, and so she is 10 centimeters taller than the average, and so all they're saying is that's roughly 2 times, like 2 standard deviations away from the mean.
Okay.
That's all it's really saying.
So that makes sense. If you scroll down a little bit, keep going.
Were you talking about like this formula here?
Yeah, maybe it was that. Yeah, I was trying to understand why that was division.
Okay, so this one is using a different equation, because up there they were just looking at how many standard deviations she was away from the mean.
Okay.
But this one is using like it's called the z-score formula. So like this is how tall he was. This was the mean. This is the standard deviation. And so you do that right there, and that gives you your z-score.
Okay.
And then with your z-score, you can come down here and do a bunch of different stuff.
Okay.
So if you wanted to find out how many people were shorter than him, or like what proportion, you could just type in his z-score, say it's like 1.5. And you wanted to see how many people were shorter than him, you would click all the boxes underneath him, which would be like 93% are shorter than him.
Okay.
Does that make sense?
Yeah, that makes sense.
Okay. And then if you wanted to do like how many were taller than him, you would click on the other side of his z-score.
Okay. Thanks.
I don't know if I really explained it that well, but that's
it makes sense.
That's kind of what it's doing. So.
Okay.
If you guys want, we can watch one of the video tutorials for number 6, just so we can kind of walk through it together. Because they're only like, he goes through like one problem in like a minute. So I mean.
Oh, okay. Yeah, let's do it. Okay. Do you want to pull it up, or you want me to pull it up?
I can pull it up real quick.
Okay.
Scores on the quantitative portion of the GRE are approximately normally distributed, with mean mu equals 150.
You guys can hear it and everything?
Mm-hmm.
Okay.
0.8, and standard deviation of sigma equals 8. Okay, those first two numbers are pretty easy to get. They just come straight from the chart right there under the GRE scores. Okay? Now, part A says what proportion of the people who take the quantitative portion of the GRE will score above 165. Okay, so if you remember our z-score up here, the formula, we're going to use that to solve this question out. So our 165 is the score that we're looking at. It's the observed score that we're going to be testing, minus the mean, the mu, which was 150.8, divided by the population standard deviation, which they told us was 8.8. Okay? So when you plug that in to the calculator, you come out with 1.6136. Okay? And then in order to find out what proportion of the people who take the GRE will score above that, we're going to take this z-score, and we're going to plug it into the normal probability applet. Here's the normal probability applet, and if we plug in the z-score that we just got, the 1.6136, and we want to make sure that we shade this upper portion because we want to know those that scored above that. Then we get 0.0533. Okay, so that area represents the percentage or the proportion of people that served, or that, that received a score higher than 165. Question B. If a student score is in the 10th percentile, what would their corresponding z-score be? Okay, so this one is actually found by just simply using the applet. Over here on the applet, first let's highlight the area that we're looking for. We are looking for the 10th percentile. So we know that's going to be less than half. So we only need this very bottom one. We're going to be typing in the area that we're looking for. Okay, that 10.10, which represents the 10%. So these group right here scored they are the lowest 10%, or the 10th percentile. Okay, so in order to find the z-score, we just type it in there and it pops out right here. So the z-score is negative 1.282. What is the quantitative GRE score for a student who scores in the 10th percentile? Okay, now we're going to take that last question and take it one step farther. So we have our classic z-score, but now we have the z-score, and we have the z-score, but we're missing the value. That's what we're looking for. What did that 10th percentile student score? So we type in we input what we know, and we know a few of these values. So we know that the z-score is the negative 1.2282 is equal to, we're going to be solving for x, and we're going to minus the mu, and the mu hasn't changed, so the mu is still 150.8, and the standard deviation is still 8.8.
So, and then he just solves for x. Do you guys know how to do that? Like manipulate that equation to solve for x?
Yeah.
Okay. So that's pretty much all that lesson was about, was just using that equation. So.
Okay.
It's not too bad.
Yeah, it's just a lot going on.
Yeah.
Sorry, I have to charge my laptop. Just 1 second.
Okay. Hey, Shauna, were you able to do the prep work? Or did you have any questions on it?
Okay.
Yeah, I did some of it, and I don't know. I think I'm just gonna have to keep going, like looking at it again and again.
Okay.
I'm just going through it.
Okay. And like I said, I didn't really know how to do all the problems, but then I just looked at those tutorials, and it helped a lot. So.
Okay. Yeah, I didn't look at the tutorials, so I probably should.
All right. So should we try out the quiz?
Yeah, we can do that.
Okay. Let's see how it goes.
Okay, true, true. The total area under a density curve must equal 1.
Isn't it 1? Yeah.
Yeah, 1.
Under certain circumstances, a density curve can drop below the x-axis. I don't think so.
Yeah, I think it has to be.
It can't be negative, right?
It has to be above the horizontal axis.
Yeah.
Oh, wait.
No, wait. Horizontal.
I think that's true because your x-axis and your y-axis. Because if you look below, it goes into the negative for the x-axis.
Oh.
But it says drop below the x-axis, but so I think that's false because I think it has to stay above the x-axis.
Yeah, I agree.
I mean, there weren't any examples of it being below.
Yeah.
Right?
Right. Okay.
So let's see.
Yeah, we were right. It has to stay above.
Okay.
Okay.
And they're also symmetric, so that one's true. Number 5.
That's all right. Okay, so we have true, true, false, true. No.
Yeah.
Sorry.
True,
yes.
true, false, true.
True.
Yeah.
Okay. Thank you.
Which of the following elements of the figure represents the z-score? That's C. Number 7, what did you guys get?
Which of the following elements of the figure represents the probability that the z-score will be greater than?
Thousands. Isn't that? Is that B?
Yep, it is.
And that's because it's in the area to the right of what would be 1.
Yeah, yep. Yep. What proportion of the data? Okay. So that would be 68%. Because this is kind of what it's saying. 68%. Where is it? Have you guys read about this 68, 95, 99 rule?
I've read about it a little bit.
Me too.
Okay. I'll just show you here real quick.
Okay.
So this is like 68% of the curve right here. And then, actually, let's do, where is it? There's a picture on here somewhere. Oh, okay, right here. So see this right here, this is 68%. And then all of this from like here all the way up and over, so all of this is 98% or 95%. And then all of from here all the way over to here is 99% of it.
Okay.
So So it's saying the 68%. So this is saying that this is the mean. So this is 1 standard deviation,
Okay.
2 standard deviations, and then 3. That. Okay. Suppose, so number 9, right?
Yes.
Okay. What proportion of values from this random variable will be between?
Wait, you added that picture. That's yours.
That's my profile picture.
Sorry, I thought that was my profile picture.
Okay.
What?
So,
Okay, let me get to that in the applet.
Yeah, palm trees.
I have it.
Not there, not there. When I got here, there was a church building.
I want to know what proportion of the values from this random sample will be between -2 and 2.
Oh wait, I missed number 9. What did you guys get?
That's the one we're working on right now.
Oh, okay, sorry.
Oh, -1 and 1.
-1 and 1. There it is. Okay.
So
Oh.
you put in,
1 and 1.
let's see if I do this right. -1.
So you only have to put it into one z-score and then just click enter and then
it
for
does
you.
the other one. Oh, nice. Okay, so it wants to know what is the random variable. Oh, wait. Wrong question. And so I highlight the blue in the middle since it wants to know what's the in between.
Yep.
So I get 0.6827.
Yeah. So that's just saying, yeah, that's just saying like 1 standard deviation.
And it only wants 3 digits after the decimal. So 0.683.
Yeah.
Yay. Okay. So it wants the same things, and then this time it's -2 and 2.
Yep.
-2. So it's 0.955.
Yep.
I like this question.
Yeah. So number 12.
Wait, hold on. I'm still on 11.
Oh, sorry. My bad.
Then it's minus. Okay, I got 997.
Yep. 0.997.
0.997.
Yeah, your phone's in set.
Does it matter if we put the 0? I guess I should just put the 0 in front of the decimal just in case.
Yeah.
Okay, number 12. Look carefully at your answers from the last 3 questions. What do you observe?
So the values match the 68, 95, 99.7 rule?
Yep. That is it.
Nice. All right, 13. Whoa. Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the U.S. The protein requirements is given in terms of the number of grams of food quality of good quality protein that must be consumed each day per kilogram body of weight.
So that's just a bunch of garbage. So we can just
Okay.
so all we need is like the population mean protein requirements. We just need the mean and the standard deviation.
Okay, so the
All that other
mean,
stuff is just mumbo jumbo.
that made it look really hard. Okay, so the mean protein for adults is 0.66 and the standard deviation is 0.07. And so we use that info to answer the questions.
Yep. So we need to find the z-score because we have, let's see, what proportion of the population have a protein requirement that is less than 60?
So would the formula be 0.60 minus 0.66 over 0.70 or 0.07?
I think so.
So
So it goes
the
0.66 minus 0.6. Oh, no. It would be what proportion? Okay. Yeah. So we go 0.6 minus 0.66 because that's the mean,
Okay.
divided by the standard deviation of
0.07.
0.07. So that'll give us a score.
Did you guys get a negative number?
Yeah, so that's the negative z-score, so we can just plug that in on the left side of it.
Negative side, yeah.
So you come and plug it into your probability applet.
Oh, I got negative 0.857.
Yep, 8 point. That is what I got.
Okay.
So do you
So the
actually...
question...
Oh.
Sorry, what was that?
So we put negative in the answer as well?
If you put it in the negative side, it should just do it automatically.
Oh yeah, I meant like when we plug in the answer, do we put negative 0.857, right? Like you add the negative in there.
Oh,
Okay.
for number 13.
Yeah.
That's not the answer yet. We have to plug it into the applet first.
Oh.
Yeah.
Sorry.
Because in the answer would that would be the area.
That would be the area. Okay.
So I'm gonna share this. Let's see. So once we have that score, we plug that in here. 0.8. It rounded it for me. And so the question asks, what proportion of the population have a protein requirement that is less than 0.6? So we found our population, so we have to include that one and that one. So it's, because this is a z-score, wait, let me think.
Yours looks different than mine.
Really? What does yours look like?
It looks like... Oh, I'm still... Oh my gosh. Do you guys see that?
Oh, yeah.
That looks crazy. Okay. Can you see that?
Yeah, so what did you put into your z-score?
I put in minus 0.857. Oh, wait. Shoot. No, I did minus 0.857. Am I missing a zero?
So it's 0.08, right?
How did you get 0.08?
So our equation was 0.6
minus
0.66. divided by 0.07.
0.
Oh, yeah. Yeah, you're right. I'm sorry. You are
Okay.
right. I just put an extra 0 in there somewhere.
Okay. Thank you.
So the question is, what proportion of the population have a protein requirement less than 60? Do we go off of what's below this one, since we got a negative z-score?
I would say yes.
I would say so too, because last time we got a positive z-score, we went off of what was above it, right?
Yeah, and it wants below it.
Yeah. Okay, so it'd be
0.60.
should be 0.19. 191.
0.196.
Yeah. What proportion of the population have a protein requirement more than 0.60? So we would do all of these except for that one.
I get 0.804.
Like that?
Yeah. No, wait.
Okay.
No, 804.
Okay. Yeah. There we go. Okay. So now we got to do the whole thing over because we have a different x value here.
So just switch off the first number to 7.
So z equals 0.7 minus 0.66 divided by 0.07. Is that making sense, Shauna? Sorry, I haven't really been asking, but.
So I think I'm a little confused. So you guys you're adding the 0.7 to the not the z-score, but the other one.
So where it would be the x in the z-score formula.
Okay.
Yeah.
So we're on 14 still, right?
No, we're on 15 now.
Oh my goodness.
Where did you leave off?
I got the 0.196.
Okay.
Okay. So did you see how we got that though?
Yeah.
Do you
Okay.
have your normal probability applet up? That kind of helps to kind of like plug it in.
Yeah.
I know it's kind of like going a lot of back and forth between screens.
Yeah.
You sounded lost.
Oh, it's okay.
We can go over it again.
Because it is kind of confusing, but once you kind of get it down, it's a lot easier to kind of where the numbers come from.
Yeah, so what helps me is to write everything down like on actual physical paper instead of typing it. So I have the z-score formula written at the top of a paper, and then at the bottom of that I have x means observation, the little o means standard deviation, and then the little u means mean.
Yeah.
So I know like what x is referring to when I look at the formula, and then I just like plug it in.
Okay. Yeah.
So I don't know if that might help.
No, yeah, that helps.
So then, because like the only thing that'll change is your x value. So for 13 and 14 here, this was our x value. So we use that to plug into our formula. So we went 0.6, which is our x, minus the mean, which is 0.66, divided by the standard deviation. So all we're doing is plugging that into the formula.
Okay.
And that gives us our z-score, which for the first one was 0.0857. That was the z-score for this one. Then you come up here, plug that one here, and that's what you get.
Okay.
So when it was asking like what proportion will be less than 0.6, since it gave us a negative z-score, you would highlight everything below the negative z-score.
Yeah.
Does that make sense?
Yeah.
Sorry, my voice is going away.
No,
So then Then for 14, you just do the opposite. What would be more than 0.6?
Okay. Yeah.
So then you come up here and just kind of highlight everything else besides that.
Okay.
Does that
Yeah,
make
that
more
makes sense.
sense? Okay.
Yeah.
Okay. So then for 15, we do the same thing, but we change 0.6 and put 0.7. So we use the same formula, the z equals x minus the mean over the standard deviation, and we just change the 0.7. So.
Okay. Yeah.
Do you want to try that one?
Yeah.
See if you, and then we'll wait and see if it's the same one we got.
So it's 0.70 and then minus 0.66
Yep.
over 0.07, and that'll give me my z-score.
Mm-hmm.
Yep.
Okay.
That's right.
1 second, let me do it on my calculator. Zero minus. Okay, so it's 0.571.
Yep.
Yep.
Okay.
So then you come up here. So what's the question asking? Will be less than 0.7.
Mm-hmm.
So then what would you do after that, once you have that?
So you put it in the positive z-score?
Yep. So it's 0.571. You hit enter, and the question asked will be less than. So which side would we'd probably want? We want this side highlighted because we want everything less than that positive z-score.
Yeah.
So that's just saying that 71% or 0.716.
Okay.
Does that kind of make more sense now?
Yeah, that makes sense. Thanks.
It's pretty confusing. The videos actually help a lot. That's kind of how I learned how to do everything, to be honest.
Okay, yeah.
Oh, wait. Hold on. So you did, I only highlighted all the way to the left, and you highlighted the middle part?
I don't care.
Yeah, because so what it's asking, it's saying everything less than 0.7, and since 0.7 is here, this is like the z-score for 0.7. So anything above it will be above 0.7. Anything below will be below 0.7.
Makes sense. Okay. I was just going off of the below, so minus. Okay.
Yeah. If the z-score would have been negative, we would have gone just that. But since the z-score was positive, you have to include this part too.
Oh, I see.
Yeah. Okay.
0.716. Okay, so 16?
No,
Yep.
he's not here at all. He's not here. Sorry. Sorry, I had this in my head. My ear.
So, would you need to plug those both in?
So see this question right here, on my right side over here? Oh, I don't know if you can see that actually, sorry.
No.
So it's asking the same type of question. So
Okay.
what is the probability that a randomly selected particle has a speed that is between 1500 and 2500?
Uh-huh.
So this homework question did the same exact thing. It went from one x to a different x.
Yeah.
And so we just take
The two scores from both of those?
yeah, the two z-scores and find the difference between them, and that's our answer.
Okay.
Wait, let me give it a try before you say the answer.
Okay.
Yeah, let me do it.
So just remember, it says that it has to be positive, so you want to subtract the bigger one. Yeah, just make them positive, if that makes sense.
Okay.
So remember, we're not using these numbers, we're using our z-scores that we found first.
Okay.
Oh, that looks so weird. It's like, yeah.
Oh, I wrote that all over my page. Which one was it?
Nothing. Just smiling. I know how to smile. You know the smile? That's good. That's right. That seeds. 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 Your seeds? Yeah. No, not the seeds, but it's a lab reading that I have to do for tomorrow. Made Tiffany's. She told me.
Is that for breakfast, Josie?
Huh?
Is that breakfast? Lunch. Well, and one biscuit. And some gravy. Now tomorrow I'll have another biscuit and some more. And then we got the figure yourself for that online. I don't know.
I keep getting negative numbers.
So which numbers are you working with?
Maybe these are. So I have minus 0.857 and 0.571.
Yeah, so go do the 0.571 minus the 0.0857.
Did you get 0.285?
Nope.
No. Well.
Okay, I'm sorry. You said, do I have the wrong numbers here?
Nope, you have the right number. So look at the right side of my screen. So for, let's see, for 0.7, that was our x value.
Right.
The z-score
Well, that looks weird.
was
Like the black up there.
0.571,
Yeah.
and for 0.6, the z-score was 0.0857. No probability that a randomly selected person will have a protein requirement that is between those two. And so from the video, he just...
Did you just get rid of the negative on the 0.857?
Oh, I forgot. Let's see. Oh, okay, hold on. Let me think for a second.
Okay.
Yeah,
So
that's what I was thinking, because that is negative.
So it would be like 0.57 minus a minus.
So it'd be positive.
Yeah, so that'd be a positive.
So, did you get 0.286? Oh wait, but if it becomes a positive, then it's add D.
Oh, my calculator wasn't doing the minus. Okay.
Okay.
So,
You know, there's been a couple people that have.
So
1.428.
Ice fishing and then
no, because this is 0.08.
like no, he found
Yes.
0.08, not 0.85.
But like everyone has said.
So
85.
571 plus 0.0857.
Yeah. How would you?
Let me try that one more time.
Are you sure it's 0.08?
It's 0.8.
Why do I keep doing that? Yeah, you guys are right.
I was was like,
That's okay.
I'm so sorry.
No, you're fine. Okay, so I'm getting 1.428.
me too.
Okay. So 1.4.
Is that what you're good with that?
Yeah.
Yeah. So
Okay.
That was really a dumb moment. Sorry, guys.
You're good.
Where's my quiz? There it is. 1.428.
Hey, no. Good enough.
2.8.
Well, it was getting.
This question over here to the right was the same type of question. What is the probability? You see this one right here?
Mm-hmm.
So that's where I went off of. That's how I found that answer.
Okay.
All right. Find the 35th percentile for the protein's requirement for adults. So let's just write. Is it talking about? Oh man. Okay. So let's write down our Z formula and write down what we know.
Okay.
So we don't know X. That's what we're trying to find. So Z equals X minus 0.66, because that's our mean, divided by 0.07.
Sorry.
Let's see. And for this one, I remember this was in Brother Richmond's video that he posted. This 35th percentile is the area. So if we come here and put 0.35 and hit enter, that'll give us, we'll be able to find the Z-score from that.
Okay.
Oh.
And the only way I know that is because I watched the video. So.
Okay.
And then I want.
So then you'd go you'd use the Z-score 0.385 equals X minus 0.66, 0.07, and you would solve for X, and that would be your 35th percentile.
Do you always use the positive?
That's what he did in his video, so I'm guessing because a percentile has to be positive. So
Yeah. Good point.
So then it's 0.385?
yeah, so that would be your Z-score that you plug back into your formula.
Hey.
And then, so your formula ends up looking 0.385 equals X minus 0.66 divided by 0.07. Because you have all the other numbers now, all you're solving for is X.
Okay.
Does that kind of make sense?
Yeah.
Wait, what did you guys get?
1 second. Plus 0.66. I got 0.68695.
I think I veered off somewhere.
Yeah, me too.
I got 0.408.
Okay, so let's see. You guys have your formula set up like this, so 0.385 equals
X
X
minus
0.66 divided by 0.07.
Yep.
So first you do 0.07 times that to this, right?
Yes.
And then add 0.66.
Hold on, let me try it again. 3.85
0.3
times 0.09. So I get 0.2695 when I multiply the 3.85 times 0.07.
Yep, and then you add 0.66 to that.
Oh.
And so that's where I'm getting 0.68695.
Oh, that's right, because it has to equal 0. Okay.
So then it becomes 0.687.
Yep.
Okay.
So then to find the 80 percentile, we do the same exact thing.
Okay.
Do you guys want to try it without my help this time? And then we can kind of collaborate and see if we got the same thing.
Yeah.
Okay.
Or 80th. I think I know what I was doing wrong in the last problem. I had the wrong decimal point in the wrong place.
Oh, okay.
Okay.
Okay. I got 0.720.
Pretty much. I got 7.719.
Okay.
So let's see. Let me
Mine
make sure I did.
by
I mean, that's pretty much the same answer. I just don't want like the computer to tell us we're wrong.
Yeah, I think I just rounded it.
Wait, what did you guys get?
I got 0.719 or 0.7189, and then I rounded up the last digit.
The last digit, okay.
Okay, what did I do wrong? Let's see. New paper. So I got the z-score was 0.842
Yep.
equals x minus 0.66 divided by 0.07.
Okay.
Oops. And so I multiply 0.842 times 0.07. That's 0.05894 equals to x minus 0.66.
Right. And then you add 0.66 to the other side.
0.66. Oh, there we go. 0.71894.
Yep.
Okay, yeah.
I guess I just had to say it out loud.
Alrighty. That's it. Do we want to submit?
Yeah.
Oh, wait. How you're doing how many decimals? Just 3 or 3 places?
Yeah, so I went 0.719.
Okay, and number 17 was 0.687.
Why are you?
Yep.
Okay, I think I got everything.
Number 16 we said 1.428.
Yes.
Okay.
Are we all good?
Alright.
Yeah.
I think so.
All right, let's submit.
Our 90. What did we miss?
Oh no, the last 16 and 17.
I wonder if we just rounded. Let's see. How did we miss 17? Because we did 18 the exact same way.
Yeah, that's weird.
Okay. So let's try that one again. I'm
Okay.
curious.
Me too.
35%. 0.35.
Yeah, what?
Yeah. 35. So I got the same z-score. 0.385. 0.07
Excuse me?
plus
On the
0.66.
page.
Oh, how the heck did that happen? I got a different answer this time doing it.
Oh, me too. Oh, wait, no. I didn't.
Times
0.6869. And then we rounded it to 7. 0.687. Did you get a different number from that?
No, that is so weird. How did we? Because that's the right answer. I mean, that's how you do it.
We can email him.
Yeah.
Yeah,
Maybe we weren't supposed to round.
Maybe.
But it doesn't.
On the other ones.
Yeah.
Oh, for number 16, we were supposed to use the probability numbers up here.
Oh.
But that's so weird because that's not how they did it in the homework.
Yeah.
I don't know. But I guess a 90's not horrible. So.
No, that could be worse.
Yeah.
I
All right.
think. Well, thanks for explaining this lesson.
No problem.
And honestly,
Hopefully
yeah, no, honestly, it helps like hearing it from someone and then like working it together.
Yeah.
Okay.
Alrighty, well. So same time next week?
Yeah, for sure. And then I guess if you have any questions with the homework, we can still help each other out.
Yeah. Hey Shona, how does it sound if so we were talking about if we aren't on by like 8:45 or like 50, let's just say like 15 minutes after our starting time, then like the rest of the group will go ahead and start unless we like hear from you. Does that make sense?
Yeah, that sounds like good.
Okay. I mean that'll go the same for everybody, so
Yeah.
just so we kind of aren't like waiting around wondering what's going on.
So are we for sure starting at 8:30?
Yeah.
Okay.
Yep.
Sounds good.
Alrighty.
8:30. All right. See you next week.
Bye.
Bye.